Hi everyone, this is another video from my CCNA series, and in this video we are going to talk about RIP, which is Routing Information Protocol, and how does it work. Basically this is a dynamic protocol. In the last video we studied about how we statically configure a route in a Cisco router. But in this video we are going to see that how we can configure this dynamically, means the route will be propagated automatically between the routers. So we'll see the example, we'll see all of that. So let's begin this video. So let's begin with what RIP is. So it is, again, I told you that it is a dynamic routing protocol. Dynamic means automatic. Suppose we have four different routes. Four different routes are connected to each other, right? Like this. And suppose there is a PC, there is a PC, and there is another PC. First of all, let me explain the difference between static and dynamic and why we use dynamic protocols. Why we don't just go ahead and use static routing protocols. So suppose I have one route here, route 1, route 2, route 3, and route 4, right? And all of these four routers know all of these routes, like route 1, 2, 3, and 4. Suppose the cable between this router and this router breaks down, and if we are using static, in that case we have manually configured route to every single router, right? So if this cable is cut and if this cable is also cut, so connection to this router does not exist, right? So these routes should automatically update in their route table that okay, the connection to this route is gone. However, we configured all of the routing table statically, means manually. So we have to manually remove all of that. So it is a big problem because if this PC wants to communicate to this PC, we have configured the shortest path as this one. The PC, the traffic from this PC will go to this route. This route will say, okay, this route exists, shortest path is this, so I will send via this. However, this does not exist in real life, right? This route does exist, but this router won't use it. This router will only use this route, which does not exist. If we use any other routing protocol like dynamic route protocol, like RIP, any dynamic routing protocol, what happens that routers communicate to each other after a certain period of time. So there are different interval for different routes. These routers will communicate to each other after several periods. Suppose this cable breaks down again in the case of dynamic. So what will happen that after certain period of time, these two routers won't receive any traffic from this, and they assume that this router is dead. So they will remove them from their route table. These router also update this router that remove this from your routing table as it does not exist. All routers will update automatically. In case of a dynamic routing protocol, we don't need to set anything manually. Just we need to enable our routing protocols on these routers, and when they are enabled, when the protocols is enabled, then these will update automatically. So don't need to configure anything. Now suppose I add a new route here. So what will happen that again all of these routers would know, all of the other routers in the network, that okay, a new route has been added. So first it will update this router's routing table, then it will update this router's routing table, then it will update this router's routing. So after certain period of time, all of them will get an update that okay, a new route has been added. So this is the advantage of dynamic routing protocol. Now in this video we are just talking about RIP protocol. So RIP has basically three versions: version 1, version 2, and RIP NG. So version 1 was released in 1988, version 2 was 93, and NG was released recently. So you can see this is a very old protocol, right? And it has also some limitations, but we still use this protocol in smaller networks. The reason for that I will tell you. There is a limitation for RIP that it can only have 15 hops. Hops means routers. So it can only have 15 routers. If we try to add a 16 router in the same RIP network, it won't add. So it will drop traffic. So that's why if we have more than 15 routers in an environment, in a large environment, we don't use RIP. Now RIP version 1 was have some serious issues, like it doesn't have support for CIDR, which is our subnet. It only supports our old style of subnetting, which is class full subnetting. Then version 2 added the support for CIDR, which is classless addressing. So version 2 added support for classless and we can use. And then this RIP-NG added the support for IPv6. So if we are using IPv6 address, we will use RIP-NG. And in IPv4, we will use RIP version 2 if we are using, you know, classless subnetting, which like all of us will be using classless subnetting only. So that is the issue with RIP version 1. Now, one more thing, RIP uses UDP protocol to communicate, and that happens on port number 530. So this is also one thing you need to remember for the exam. It can come, but I don't think that it will come, but yeah, you just need to remember that. So yeah, this was about RIP version 1, version 2 and NG. Now how we enable RIP in a Cisco device? Let's see an example on Cisco Packet Tracer. So I'll go open up my Cisco Packet Tracer window, and as you can see that there are 4 routers, and this is one for one network. This is another network. This is 10.10.10.0. This is 192.168.10.0. So both are different networks. We are going to add RIP routes with the help of these routers. So we are going to enable routing information protocol in all these routers, and all the routes will automatically update. So no need to worry about that. We just need to enable RIP in these routers. So I already assigned all the, network interfaces and IP address. So this PC has, if you see, the IP address of 192.168.10.1, and this router has in SE serial 000, it has 172.168.10.1, and in SE001 it has 192.168.58.1. So I've already assigned all the IP address to the interface. You can also see here. So I will just go to router 0 and just try to enable RIP. And what are the commands for that? So we'll just type enable, then configuration terminal, and once you are in the configuration terminal, basically you can type routing. So routing is the command to enable any routing protocol. I typed the wrong command. Actually the command is router, not routing. So router is the command, and in this router you can enable BGP, EIGRP, which is Cisco's proprietary, OSPF or RIP. So I'm going to enable RIP for now. So router space RIP, and just press enter. And now see, it is configuration router mode. Now we will be having some options here. So we can set version, right? So first let us set the version as 2. So because we are using class less addressing, so we will set the version as 2. Now this is for router number 0. See, router number 0 is this one, and 172.16.10.030, 192.168.58.030 and 192.168.10.0/24. These are 3 different networks which we need to add to this RIP table of this router. So we'll just go version 2, we have done. And to add a network, we will use the network command, and in network command it will ask for network number. First we are going to add 192.168.10.0, which is a network number, and it's done. Another network we can add is 172.16.10.0, and another network we can add that 192.168.58.0. We have added all of these 3 networks to this router's routing table. That's it. That's it you need to do. No need to configure any manual routing or anything else. See, show run. If you type show run, you see router RIP version 2, network 1, network 2 and network 3. All the networks are added on this. So we are going to repeat the same procedure in all of these routers, right? So we'll go to router 0. For this router, the networks are this one and this one. For this router, networks will be this one and this one. And for router, this is going to be this one and this one. So I'm just going to quickly add this. So I've added all of these, routers. I've enabled RIP in all of these routers. And if I try to ping, so if I try to ping 10.10.10.1 from PC0, which is this PC1. So if I get a successful ping, so it means that the route is actually working and there are no issues in the routing table. So if you want to see any RIP routes, how will you identify, right? So if you go to your routing table of any of the router, you will see that these are, connected route, local route, and this is the route which is reached via RIP. So this automatically added with RIP. So there is an R in the routing table. This one is also added via RIP, and this one is also added via RIP. So see, RIP is already, in progress and adding all of these routes. So this is about it. This is about RIP configuration and what RIP is basically. And I don't think there is anything more to discuss on RIP. Please note that RIP only works for 15 routers, 15 hops. If you try to add a 16th hop or router, it won't work with that. So this is the limitation of RIP. Rest, everything is fine. The configuration is pretty easy, but how RIP works, you should only know that for the exam and how this configuration works. So that's it in this video. In next video, we'll talk about maybe floating routes or OSPF. So in this playlist, so subscribe to the channel and please like the video. So thanks for watching and I will see you in the next one.